Okay, so as far as our money formulas go, let's talk about those. So in general, if you got amount equals initial amount times 1 plus or minus the rate to the time. So that can be kind of like thinking about like annual compounding or compounding annually. So that can be used for money, but it can also just be a general exponential growth. Okay, so compounding annually. K times a year. K times a year. Ah. Okay, that's when you do amount equals principal. So that could have been a capital P for principal as well, as opposed to initial amount. Principal times 1 plus R over K to the KT. So the only difference is you've got the K, which is the number of times. So you can have semi-annually, which is twice a year. Yeah, I guess I can type that out or write that out. Semi-annually, K equals 2. Quarterly, K equals 4. Monthly, K equals 12. Weekly, K equals 52. And you're not really daily is 365. You're not really gonna have to worry about anything really other than these. Okay. So when it says every year, this is just a basic one of these. Okay. So 25,000 is the initial amount. It depreciates, so it goes down at 9%, so 0.09 to the T. And the question is, like, if this is the amount, like this is an amount formula, right? The question is, how long will it take for it to equal $10,000? So I want to solve this equation. Okay, I'm going to work this two different ways. One, I'm going to show you how we worked it when we first learned it, which is using the calculator. So, just kidding. 25,000 times 1 minus 0.09 is 0.91. Didn't need those parentheses, but whatever. 0.91, and then I want to know when it equals 10,000. So I'm going to go to window and make sure that I'm going to go so time is going to be positive, and money, the highest I need to be able to see is 25,000. Technically, I only need to be able to see 10,000, but I'm going to go 0 to 30,000. So I'm going to find this intersection. And I don't need to get close, but it's kind of fun. So, okay. So it's when time equals 9.716, basically. So after you bought it, it takes 9.716 years to decrease to 10,000 in value if it depreciates 9% each year. Okay, so now let's solve it using exponential equations. So I've got 25,000 times 0.91 to the x equals 10,000. So as far as solving goes, I want to get the x by itself, so I'm going to divide by 25,000. See the exponential expression alone. So 10,000 divided by 25,000 is basically 10 divided by 25, which is 2/5. So I've got 0.91 to the x equals 2 over 5, or you can say 0.4, I guess. Yeah, I was going to say 0.4. 0.91 to the x equals 0.4. Okay, and then if I'm trying to solve, well, you can either convert to an exponential or raise both sides to power, or no, sorry, just kidding. Or you can take the log base 0.91 of both sides. But if we just convert it, log base, so the base of the log is the base of the exponent, so 0.91 of 0.4 equals x. And so I'm going to type that in and see if I get the same thing. So alpha window, log base, number 5, 0.91 and 0.4. 9.716. So we're good. All right. So y1, y2. Okay, and then number 15. So number 15, it says, if the money given is invested in an account that compounds semi-annually at 5.7% interest, what would the equation be for the amount of money in the account? So amount equals 20,000 is the principal times 1 plus semi-annually is k times a year, so it is 0.057 divided by semi-annually, k equals 2, so divided by 2 to the 2t, and that is the formula for the amount of money at any time t. Okay, so this is how much money would be in the account after 20 years. So we would type in that expression in the home screen, and in place of t we would put 20. So yeah, okay, 20,000 times 1 plus 0.057 divided by 2 raised to the 2 times 20, and you get 61,546 and 28 cents. Dollars, I guess, 28 cents. All right. Part C, if the money given is invested in an account that compounds continuously. Oh, yeah, I forgot my continuously. So continuously, if it compounds continuously, then its amount equals principal times e raised to the rate times time. Okay? So we've got amount equals I don't want to yell during my video, but guys, I'm not convinced that we're all working. I think we're doing a lot of talking. Guys. So principal times e raised to the rate, which is 0.056 to times time. So there's my formula for the amount of money. And then how much money would be in the account after 20 years? And so 20,000 times E, which is above ln, beside 4, to the 0.056 times 20. And so it is $61,297.08 and 8 cents. Okay. So this is 5.6% compounded continuously, and this is 5.7% only compounded semi-annually. But after 20 years, sure enough, compounding semi-annually at 5.7 is better than compounding continuously at 5.6 because you got a little bit more money. So I would say semi-annually at 5.7%. Okay. Now I need to start talking about log and exponential. So in general, if you got a log equation, the exponential form, take the base of the log, x, raise it to the power of the other side, and set it equal to what is inside the log. Now you could also just do this, raise both sides to the power of x, and then do that. Then you get x to the y equals 52. So the next one is v to the u equals 36. And then going backwards, log base of the exponent is base of the log of n equals m. And for this next one, log base y of x equals 18. Numbers 20 through 25, it says evaluate without a calculator. So the idea here is to be able to rewrite the base as the same, what's inside the logarithm is the same, some power of the same base. So it's 4, log base 4, so I'm going to look at 4s, and I see that 64 is 4 cubed, So this is log base 4 of 4 to the third power. So power property says I can bring the 3 down and say 3 times this log base 4 of 4, which is 1, because these cancel each other out. So it is actually just 3. It's a terrible 3. Okay, this one, this is a power of 1, so that would just be 1. Okay, 81, I'm going to look at 81 and powers of 3 is 4. So because this is 3 to the 4th, that is 3 to the negative 4th when I bring the 81 up, right? So that answer would be negative 4. Number 23, okay, so 1 is 7 to what power? 7 to the 0. So this is log base 7 of 7 to the 0 power, meaning the answer is 0. 8 squared is 64, so this is log base 8 of 8 to the negative 2. The answer is negative 2. And 81 is 9 squared. So the answer is 2. Alright, graph each function, identify domain and range, draw and label the asymptote. Okay, so logarithms. So remember, if exponential does this, then logs are the reflection. They look like that. Okay. So whereas an exponential function has a horizontal asymptote, a log has a vertical asymptote. So let's graph it. Y equals, clear out anything that's in there. And I'm going to go to alpha trace. So, sorry, not alpha trace, alpha window. And number 5, log base 2 of x plus 2, and then minus 4. I'm going to go to the table and start being able to plot some stuff. Now this plus 2 means go left 2, so I'm pretty sure the farthest I'm going to be able to go is to the left 1 and plot a point. And then at negative 2, it's got an error message because that, whatever you shift, is your vertical asymptote. So negative 2 is the first error message. So that is my vertical asymptote. And it goes to the x-axis, so it's x equals negative 2. Let's plot some points. So, at negative 1, we're at negative 4. At 0, we're at negative 3. At 1, we're at negative 2.4. Negative 2. Negative 1.67. Negative 1.4. At 5, we're at negative 1.19. And then negative 1, and then negative 0.83, and negative 0.67. Okay, so you got to be careful because some people will only graph these points over here. Ooh. Okay, but you have to remember that this actually has this tail. So, just kidding. Window, negative 8 to 8. Negative 8 to 8. If you look at this graph, it does look like it actually gives you a little bit of the tail, but in all actuality, it gets closer and closer to the vertical asymptote, so it does something like that. Okay, so domain and range. Domain is how far left and right it goes. The farthest to the left it goes is negative 2, but it doesn't actually reach it. And as far as range, it's low to high. It goes all the way down into negative infinity. It goes up to positive infinity, but it is really slow. So negative infinity to infinity. And then number 27. So natural log is log base e. So you could type in log base e right here, but we can also just use the ln button. So natural log of x plus 4, and then plus 1. So I'm going to go to the table. I know left 4 is going to be my vertical asymptote. And there you go. So you can see the first error message. So left 4, vertical asymptote, x equals negative 4. And then we plot the points. So at negative 3, we're at 1. Negative 3, we're at 1. -2 we're at 1.69. 2.09, so basically 2, 2.38, 2.6, 2.8, 2.9, 3.07, 3.19, 3.3, I mean, we're not really increasing much, 3.39, and 3.4, so basically 3.5. Okay, so I've got these points, and then we've got this down here. Alright, domain and range. Domain is how far left and right. The farthest left it goes is -4, and then it goes to infinity. And then range is all real numbers. It goes all the way to negative infinity, all the way up to positive infinity. And that is page 4.